Hello there, Mr. Sutton here, bringing you this Algebra 2 5-4 lesson on solving radical equations and inequalities. As the title suggests, we're going to be solving radical equations, and that's also going to include equations that have rational exponents in them, and then we will circle back to do some radical inequalities. So this right here is the first of several radical equations we're going to be solving. Before we dive in and do that, though, let's define what a radical equation actually is. So a radical equation is just an equation that has a variable inside the radical, like this x inside the square root over here. If you just have a square root that has like a constant inside it, like square root of 2, that by itself does not make it a radical equation. And you might use a different technique than we're doing with this stuff to solve something like that. Now, one reason it's good to know if something is a radical equation is because these equations sometimes have what are called extraneous solutions or extraneous roots. These are solutions that will work for a modified version of the equation after you do stuff and move things around, but they won't actually work in the original equation when you plug them back in. So for this reason, on these problems, you need to check solutions in the original equation and throw them out if they're extraneous, if they don't actually make the original work. Now you might wonder, well, what causes this weird sort of behavior? And the short explanation is that one of the techniques that we use to solve these types of equations involves raising both sides of the equation to an exponent. And it turns out when you do that, especially if you're raising like a negative number to an even power, you lose some of the information along the way. So that's why it's important to go back and check every single time. So with all that said, we're going to dive into this first one. Our general approach for all these types of problems is going to be to isolate the radical and then raise both sides of the equation to whatever the index of the radical is, 2, 3, or whatever. So with that in mind, pause the video and see if you can figure out how to do this one. And then, if you got time, check your answer. All right, so to isolate the radical here, we have to first divide by this 2. So we have square root of x plus 1 equals 2. And then the index on this thing is the second because it's the second root. We don't write the 2 up there. So we have to square both sides to undo the square root. That leaves us with just x plus 1 on the left side and 4 on the right side. And then to actually solve for x, pretty straightforward, just subtract the 1. So we have x equals 3. Or does it? So this is where we have to go back and check our answer. So we're just going to plug 3 back into the original equation up here. So we have 2 times radical 3 plus 1 equals 4, question mark. I notice I have my question mark above the equals here because I'm not really sure about this. I'm investigating it. The square root of 4 is 2. 2 times 2 is 4. So we've got 4 equals 4. Ends up being what we get when we check this. If we have the same thing on both sides, that means it worked out, and 3 is actually a good answer. We've got another example lined up for you. This time, note that we have a cube root rather than a square root, so that's going to change things a little bit. Pause the video and try it out. All right, so to isolate this radical, we'll just add 1 over here. That gives us 3. And this time, instead of raising both sides to the second power, we have to raise them to the third power to undo the third root. So we end up with 2x minus 9 on the left, and 3 to the third is 27 on the right side. And then solving for x, we can just add 9 over here. That's 36. Dividing by 2, we get x equals 18. And then just like before, go back and check. So we have cube root of 2 times 18 minus 9. All of that minus 1 equals 2, question mark. So 2 times 18 is 36. 36 minus 9 is 27. So we have the cube root of 27. Cube root of 27 is just 3. So 3 minus 1. And then 3 minus 1 is, in fact, 2. So that answer also checks out. For this next problem, we have an equation that has not 1, but 2 radicals. Interestingly, that doesn't really change our steps a whole lot here. As long as you only have 1 radical and that's it on each side, you can proceed pretty much as we have been on the past few problems. So try this one out and see where it takes you. All right, so for this, I've got a square root on both sides. I'm just going to square both sides. So that's going to give me x plus 2 and 3 minus x. And then just solve for x here. So adding x over to the left, we have 2x. Subtracting 2 from the right side, we have 1. And then dividing by 2, we have x equals 1/2. Now let's check our answer. So we've got 1/2 plus 2 and 3 minus 1/2 inside square roots. This is going to be 5 over 2 on the left side inside a square root. And over here we've got, let's see, 6/2 minus 1 is also 5/2. And we could square root both of these, but I mean, if you square root the same thing, you end up with the same final answer. So this is a good answer. So at this point, if you're doing the non-honors CP version of this lesson, then this is the end of part 1 of 3. If you're doing the honors, then we're going to keep going and do one more problem before your part 1 ends. So welcome back, whether you're continuing on for the honors version of the lesson or rejoining us from the CP version. So this next one, we have x plus 1 and square root of 7x plus 5. This is going to turn out a little bit different, although it may not look like that at first. So pause the video and take a little time to see if you can untangle this one. All right, so we've already got the radical isolated just like before, so we're going to square both sides right off the bat. That's going to give me x plus 1 quantity squared on the left side and 7x plus 15 on the right. And I'm going to probably want to expand this stuff on the left side and move everything over. This is going to end up being a quadratic, so it's a little bit different than the other ones, which up to this point have all ended up being linear after we got rid of the radical. So over here, this is going to be x squared plus 2x plus 1. And then the right side isn't changing just yet. And then moving everything over to the left, 2x minus 7x, that'll be a negative 5x. And then 1 minus 15 is negative 14, all of that equaling 0. All right, well, let's see. I think we might be able to factor this. Two things that multiply to negative 14 and add up to negative 5. 1 and 14 doesn't work. The only other option is 2 and 7. Positive 2 and negative 7 adds up to negative 5. So I can break this up into x plus 2 and x minus 7. So that lets us have two answers here. So we have x equals negative 2 for that first parentheses and positive 7 for the next one. Now this is going to seem a little bit tedious, but we are going to go ahead and check our answer in the original equation, check both answers, just to make sure they actually work. So let's do negative 2 first. We have negative 2 plus 1, and then the square root of 7 times negative 2 plus 15. Negative 2 plus 1 is negative 1. Over here, this is negative 14 plus 15, which is just 1, so we have the square root of 1. The square root of 1 is positive 1, not negative 1. So those don't actually come out the same, and that means that we actually have to eliminate this extraneous root of x equals negative 2. So every now and then we catch one. Let's see if 7 is also extraneous. So we'll have 7 plus 1 equaling 7 times 7 plus 15. 7 plus 1 is 8. This is going to be 49 plus 15, which is 64, square root of that. And 64 square root is 8. So it turns out 7 is a good answer. Now, just in case you're wondering, if 7 had also turned out to be extraneous and had to be eliminated, then we would just write no solution if none of our answers actually worked out. But fortunately, one of them did. So in any case, if you were doing this as part of the honors lesson, this is the end of your part 1. Feel free to pause the video and do some radical equation practice, and then rejoin us. Next up, we're going to be taking a look at rational exponents in equations. So welcome back. If you are rejoining us from the honors or continuing on with the CP, we have an equation with a rational exponent. Now we know that these rational exponents are really just radicals in a different form, so we can use most of the techniques we've been doing to untangle these things. One little tip though that I would recommend before you just go and convert this to radical form, it's actually easier to do the first step without doing that. So namely, we can undo these fractional exponents by using the reciprocal power on both sides once we have this exponential piece isolated. Then after you undo it with the reciprocal power, at that point it might be better off to convert it to radical form. But there's lots of ways to do these. Pause the video, pick a path, and see where it leads you. All right, so I am going to go with my own advice here. I'm going to isolate my exponential part here first by subtracting this 2. So that's 8 over there. And to get rid of the 3/4 power, I'm going to raise both sides to the 4/3 power. Now the reason this works is because when I'm raising an expression with one exponent to another exponent, I multiply the exponents. So 3/4 times 4/3 would actually just give me an exponent of 1, which I can then just kind of pretend isn't there. So raising both sides to the 4/3, we're just going to have 2x on the left and 8 to the 4/3 on the right. And at this point, I'm going to find it helpful to convert to radical form. So this 8 to the 4/3 is really the cube root of 8 to the 4th power. And again, you have a choice whether you want to apply the 4th power first or the cube root first. Usually the root is going to make your life a little bit easier if you take care of it right away. The cube root of 8, in this case, is 2. So we have 2 to the 4th. 2 to the 4th is 16. And then dividing by 2, we end up with x equals 8. So a little bit of a journey, but we got our answer. Let's go ahead and check it. We still have to check because there's a radical really kind of implicitly involved in this. So we have 2 times 8 to the 3/4 plus 2 equals 10. So this is really 16 here, and I'm doing the 4th root of 16 raised to the 3rd power using this fractional exponent. 4th root of 16 is 2. 2 to the 3rd power is 8. And then 8 plus 2 gives us 10, which matches the other side. For this next problem, we have x plus 30 to the 1/2 power equals x. So another fractional exponent. Pause the video and see if we can use what we learned on that last example to help us out on this one. All right, since I've got my fractional exponent piece isolated here, I'm going to use the reciprocal power right off the bat. The reciprocal of 1/2 is 2 over 1. So basically just squaring both sides. That gives me x plus 30 on the left and x squared on the right. This is a quadratic, so let me just get everything over to one side. I'll just subtract everything over to the x squared side. So we'll have x squared minus 30, minus x rather, and then minus 30. All of that equals 0. This looks like it should be factorable. Things that multiply to negative 30 and add up to negative 1. Well, 1 and 30 doesn't work, neither does 2 and 15, neither does 3 and 10. 5 and 6 works if I have positive 5 and negative 6. So we have x plus 5, x minus 6 equals 0. Zeroing each of these out, we have x equals negative 5 and positive 6. And just like always, let me check both of those and make sure they both work. So we'll do negative 5 first. We've got negative 5 plus 30 to the 1/2 equals negative 5. Or does it? This is 25 to the 1/2 power, which is the square root of 25. And the square root of 25 is just 5, plain old positive 5, which does not equal negative 5. So we have to get rid of this negative 5 answer. That one's extraneous. Let's try 6 out now. So we have 6 plus 30 to the 1/2 equals 6. This is going to be the square root of 36 on the left side. Square root of 36 is 6, so that works out, and our only answer for this one is 6. So at this point, if you're doing the CP version of the lesson, this is the end of part 2 for you. Pause the video, try out some of these fractional exponents and quadratic radical fun, and then rejoin us for some application and some inequalities. If you're doing the honors, then let's just keep going. Welcome back. If you are rejoining us for the CP class or the honors class, you never left. So let's do a real-life application. There's a lot of these radical applications. This one involves a hurricane, which is kind of cool. So the mean sustained wind velocity in meters per second of a hurricane is modeled by this equation, where P is the air pressure in millibars at the center of the hurricane, and V of P is our velocity. So we want to estimate the air pressure at the center of the hurricane when the mean velocity is 54.5 meters per second. Okay, so what are we actually doing here? Well, if we're trying to get the air pressure, we're actually solving for P. That means we've got to replace V of P with something. And in this case, it looks like they want us to plug in 54.5 for v of p. So that's how we have to kind of approach this problem in the beginning. And this leads us to solving a radical equation. Shocker there, right? So pause the video and see if you can go the rest of the way and find those millibars. All right, so our first step on this, and I'm actually not going to use the calculator until the very last second here. So we're isolating our radical term. That'll mean dividing by 6.3. So I have 54.5 divided by 6.3. And again, I'll wait till I crunch the numbers on this. Next up, we have to get rid of the square root by squaring both sides. And then finally, I have to isolate p. So what I'm going to do is add p over to the left and subtract this glop of stuff over to the right. So 1013 minus that squared monstrosity is going to give us our answer, maybe. Let me go to Desmos and plug this in. All right, so we've got 1013 minus, I'll open a parentheses here and do a little fraction in there, 54.5 divided by 6.3, close that, square it, and it comes out to about 938.16, and that's again going to be in millibars. But wait, let's check our answer just to be sure. So we're using this equation right here. So we've got 54.5 equals 6.3 times square root of 1013 minus this. 1013 minus that, let's see, it was 938.16, that's about 74.84. And then we need the square root of that. So square root of 74.84, and let's actually put a 6.3 out in front. So that comes out to about 54.5. And it's going to be a little bit inaccurate because we rounded off here, but yeah, this definitely works. For the next couple problems, we're going to be solving some radical inequalities. So there's a general strategy we're going to use on this, which is basically going to be to pretend that this inequality symbol is an equal symbol. So general strategy, pretend it's an equation rather than an inequality, and solve for x, keeping the inequality the same for every step of it. And whatever techniques you would use to solve 3 radical x minus 1 equals 12, we're going to do that in a moment. There are two kind of special cases that we do have to be aware of as we're using this general strategy, though. So the first special case is we have to reverse the inequality if we are multiplying or dividing the whole inequality by a negative. This is just an old rule of inequalities that you probably saw back in the day and maybe forgot about, but it's still a thing. If you multiply or divide everything in the inequality by a negative, you have to reverse the inequality. If you just distribute a negative or something on one side, then that does not affect the inequality at all. Now, the other special case is if we have an even radical, like we do in this case, then making the radicand, the stuff inside, non-negative is going to be part of the solution. So you need to make sure that people can't plug in x values that would cause you to take the square root of a negative number. So that's also something to throw in when you're writing your final answer. So with all of that, pause the video and see if you can figure out what the inequality solution for this is going to be. And I'll give you a hint. It should be another inequality with an x in it. All right, let's see how this went. So we're going to divide by 3 to isolate that radical. That's going to give us 4 over there. And since I'm not dividing by a negative, I keep the inequality pointing the same direction. Next up, I'm going to square both sides. So that's x minus 1 and 16. And again, I'm just going to keep the inequality pointing the same direction. Next, I'll add 1. So that's going to be x less than or equal to 17. And this, unfortunately, is not the whole answer. Because we have an even radical, we have to make sure the stuff inside is going to be greater than or equal to 0. So x minus 1 has to be greater than or equal to 0. Otherwise, this will fail. That means that x itself has to be greater than or equal to 1. So putting this together with our answer from just straight up solving it there, we see that if x is greater than or equal to 1 and less than or equal to 17, we can write 1 less than or equal to x less than or equal to 17 to put all of that in one answer. Alrighty, we're going to do one more of these inequality problems. pause the video and try this cubic inequality. All right, so first step, we're going to divide both sides by -2. Now, when we divide by a negative or multiply by a negative, we have to remember to reverse that inequality. So this is going to be cube root of x plus 6 is less than -4. So that's a key switch right there. Then everything else is kind of the same, except instead of squaring both sides, we're going to cube both sides. So this will be x plus 6 less than -64, the cube of -4. And then we subtract 6 to get negative, let's see here, -70. Now you might be wondering, do we need to make sure that x plus 6 is greater than or equal to 0? We do not. Because this is an odd inequality, or I should say an odd radical, it's okay if there's negative numbers in there. That's only a problem with even radicals. And that wraps up this lesson. Hopefully you found a most radical solution to all the problems facing you in life. Till next time, Mr. Sutton signing off.